As a statistician, you can do a lot of measurement on that person. And some of the things you can measure will then be classified under two major headings. One of them was quantitative and the other was qualitative. And so I remember you gave me a lot of examples, your age, your height, your weight, level of education, and all of these. And then later on, we classify these under the qualitative and then the quantitative. Now, under the qualitative, we learned that we had the nominal and then the ordinal. Nominal is a list of names. An example was the marital status: single, married, divorced, separated, widowed. And then we talk about the ordinal, which is also a scale, but then this one comes, it's not just a scale, but then it has order attached to it. And then we talk about rating of some product: good, bad, never want to buy it again, or probably your test grade A, B, C, D, and F. I think nobody wants F in this class. Yeah, and from there we talk about the quantitative data, which we said it's kind of not easy to differentiate between the two, but hey, one can easily split the two apart. So we said we have the interval scale, which measures the quantitative values where the zero is significant, whereas the ratio is when the zero does not play an important role. So for example, we said if it's a interval scale, then the zero, which is the zero, is pretty significant. I gave you some examples. One was temperature. When the temperature is zero, it doesn't mean it does not exist. It means we are freezing, like what we've been experiencing recently. I hate that inclement weather, but hey, this is Boston. What can you do about it? We love the snow, we hate the cold. All right. And then we talk about the ratio, which also means that when you have a variable that possesses zero, it means absence of the characteristics. Absence of characteristics means that if the height is zero, then the height does not exist. And I think one wonderful example we gave about the interval ratio was, the interval scale was the size of a lady's dress, size zero. It doesn't mean the dress does not exist. It's zero, it's small. That means it falls under interval. So we talk about all these and then we jump on to the numbers, where we decided to then compress these numbers on a little table which we call the frequency table. Now the frequency table, as we said, has two major components: the class and then the frequency. I collected sample of your ages and then we decided to categorize that into different classes. We said before one can construct a frequency table, you will need, number one, class width. So we computed the class width by finding the difference between the maximum and the minimum number, dividing that by the desired number of classes. And from there, we had the class width. But then we're also cautioned to always round up. With the class width, you must always round up. And with that, we're able to create our classes. 17 to 22.
And that was 9.
The frequency is over here. 9.
And 23 to 28.
23 to 28. 8.
And 29 to 34.
29 to 34. 3.
35 to 40.
35 to 40. 1.
And 41 to 46.
41 to 46. 1.
47 to 52.
47 to 52. 0.
And 53 to 58.
53 to 58. 1. So this is what we had. Now when you get this information, our goal is to summarize this using a graph. That's where we were before we had to go. So we talk about the pie chart and then the bar chart And now our goal is to concentrate on the histogram, if you remember that. And I mentioned that histogram is one of the most important graphs in statistics because it kind of tells you everything about the data. Whether you have a good data or a bad data, what do you have to do about the data. The histogram will kind of give us a lot of information. But before we get to the histogram, there are some important things we want to talk about here. The first thing is what we call class midpoint. Now, for those of you who have started the homework, I believe you might have seen that. Class midpoint. Now, the class midpoint is the average of these two numbers, 17 and 22. 22. That's the average. So you put the two together and divide by 2. Before we continue, these numbers, if you look at these classes, they all do have starting points, right? And end point. These numbers we start each of these classes are called class limit. This is also another class limit. But because this is starting, the start point will be called the lower class limit. And because this guy is ending the classes, we call this one the upper class limit. So we have the lower class limit and then the upper class limit. So by definition, one can say that the midpoint is the average of the lower class limit and then the upper class limit. If average doesn't make sense, what are we trying to say is add these two numbers, divide by 2. You have the class limit. So 17 plus 22 divided by 2. What is that equal to? Nothing. Something. Take your calculators. Let's do some work. 16.5. 19.5. Because it's going to be 39 divided by 2. That's what we have. So if you want to find a class midpoint for the next class, it will be 23 plus 28 divided by 2, which is 25.5. The next will be 29 plus 34 divided by 2. 31.5. Yep. If you are finding the class midpoint, yes. Divide by 2. Do you remember the class width for this table? 6. Now look at what is going on here. Instead of moving back and forth, adding these two numbers and dividing by 2, you can use the class width. How? Look at it. We started with 19, right? Add 6. 25.5. Add the 6. 31.5. So instead of moving back and forth, you can add a 6 to this, which makes it 37.5. Add a 6. 43.5. Add a 6. 49.5. If you don't want to add a 6, just go ahead, add 53. And then the 58. If you add the 2 and divide by 2, if you add a 6, $55.5. Is that okay? So finding the class midpoint is not really difficult. Now, why the class midpoint? Why does it come in all of a sudden? It's simply because there is a graph called frequency polygon. Now, in order to draw the frequency polygon, you will need the class midpoint and the frequency. That's why we're looking for that. So if I take you to that slide, and I think we might have seen that. Frequency polygon is down here. In order to graph the frequency polygon, you need the class midpoint and then the frequency. You should find that on your PowerPoint. So that is why we are looking for this class midpoint. We are not just finding it for fun, but of course in your homework too, I think along the line you are asked to find the class midpoint. Good. Another thing that should be of interest to us is what we call class boundaries. In order to find the class boundaries, you will go to the classes because this is class boundaries. That should take us there. Now we're going to learn how to find the class boundaries. Before you find the class boundary, you need to find one thing which we call continuity correction factor. Some books refer to this as continuity factor. Others call it correction factor, but I choose to call them both continuity correction factor. Because first of all, it is correcting our data. Secondly, it's making it continuous for us. And of course, this can be done through this factor. Question is, how do we compute this continuity correction factor? Simple. I'll do an example before we put that in words, right? So let's go over here. If I want to find the continuity correction factor, the only thing I have to do here is to pick any of these upper boundaries and then subtract the preceding, it could be the preceding lower limit, or you could pick this lower limit and then the preceding upper boundary. It's all dependent on you as to what you want to do. So if you look at the first one, this is the lower limit, right? This is the upper limit. Lower limit, upper limit. I want to find continuity correction factor. What do I need? I need one of these, this lower limit and then the preceding upper limit. If another student chooses 35, then you must make sure you use the preceding upper limit. Does that make sense?
And you said the other option would be to use the upper and subtract the lower, right? Or no? Am I wrong?
Upper and lower.
No. The same line.
No, the same line? No, it doesn't work that way. Mm-mm. If you find the continuation correction factor, then it must be a lower limit and the preceding upper. Yes, sir.
So what do you do for the top one where you don't have a preceding upper limit?
I think we know that. What is the preceding upper limit? Yeah. Because that's how we learned it, right? When we were finding that, we realized that, hey, this is 29. What comes before that? 28. Now, what you do then is you find the difference between the lower limit and the preceding upper limit. What is the difference between them? And divide by 2. That is the continuity correction factor. So here, if you want to find the continuity correction factor, it doesn't really matter which of the lower and the upper limit you use. We all will end up with the same result. So in this case, if I choose 23 and 22, it will be 23 minus 22 divided by 2, which is 1 over 2, 0.5. What is this? Continuity correction factor.
What does that translate to? And what does it mean? What is the correction factor? What does that actually mean when you get the number 0.5? What is it?
It's a correction factor.
So
And
are they just gonna ask you find
nobody's going to ask you to do that. But as I said earlier on, it's going to make our data continuous. And that will be seen as we use that here.
Is it a variable? It's a variance? What is it?
It's a number.
Okay.
And we're going to use this continuity correction factor to make this data continuous. Helps a little bit. Were you here last class? We had discrete and continuous data. I guess, yeah, don't worry. You get it. It doesn't really matter. Yeah, you get it. So we're going to use this continuity correction factor to find this class boundaries. So that's what we find in this number. Great. From here, we are going to subtract this 0.5, or continuity correction factor. It's not always 0.5, but later on we will establish that it's 0.5. But for now, it's 0.5 for this table. You will subtract this 0.5 from all the lower limit. And then you will add the same 0.5 to all the upper limit. That will make it the class boundaries. Remember, we started with the class boundaries, right? We're looking for class boundaries. And question is, how do we get to the class boundaries? So like, hey, take a moment. Before you find class boundaries, one must know the continuity correction factor. And as soon as you find the continuity correction factor, you can then deduct that from all the lower limits and add the same number to all the upper limits, and that gives you the class boundaries. So what am I going to do? I'm going to subtract 0.5 from 17. What is 17 minus 0.5? It's 16.5. 2. Then you add it to the upper. 22.5. Subtract from here. What does that give us? 22.5. Add to the upper. Subtract from there. 28.5. Remember, you subtract from the lower and then add to the upper. 34.5. Subtract. Right? To 52.5. Any questions before I continue, because I'm going to add more? Question is, what just happened? And I believe that is what he wanted to know. What is that doing? Look at what is happening here. Wherever you end, that's where you start. It's kind of serpentine. We have closed the gaps between them. We have made the data continuous. So here we ended with 22.5, start with 22.5, end with 28.5. So here there's a hole between 22 and that. We have closed it. Closes the gap. That is the continuity correction factor. We're kind of correcting the data by changing from discrete to continuous. Yes?
So is the 0.5 the boundary that we got before, or is that?
If you say the boundary,
I'm not getting like where we got like the 16.5 to the 22, like
oh,
yeah, I got as far as like the continuity correction factor, and then I'm like totally lost.
awesome. So you're okay with continuity correction factor? Great. Now we're going to use this continuity correction factor to find the class boundaries. How do we do that? You deduct this one number, subtract from all the lower limits. You know these numbers are the lower limit. So 17 minus 0.5. 23 minus 0.5. That's all I did. But then into the upper limit, I added. Any concerns, any questions? Question is, why that? Is because when you go back to the slide, we have to draw a histogram. In drawing a histogram, you need the frequency and then the class boundaries. Does that make sense? So all of these are relevant to that. It's because of these graphs. And in addition to this, I think we can also find what we call class less than. I mean, for those who have taken a good look at your homework, you see all these things in there. They ask you to find all these. Why class less than? Because somewhere here, the ogive can only be graphed using the cumulative frequency and the class less than. So we need to know the class less than. This page is all about graphs. And before you can draw any of these graphs, you need the information. If you don't have it, you can graph it. So we try to find them first before we do anything. Now, if you remember from this class, from this point, we said that all the starting, the initial points are called lower class limits, right? So when we come to the boundaries, I think we can also label that. You see, we have a beginning and an end, starting point, end point, start point, end point. All the start points here are called lower boundaries. These 16.5, 22.5, 28.5, 24 down to 52.5 are called lower boundaries. And then these numbers here, 22.5, 28 down to 58 will be called the upper boundaries. Any questions? Now I said that so that finding class less than will be as easy as anything, because the class less than is the same as the upper boundaries. So like Microsoft, copy and paste. These are called the lower boundaries, and these are the upper boundaries. If I want to find a class less than, all I have to do is to copy all the upper boundaries, because the upper boundaries are the same as the class less than. So this is 22.5. I'm just copying a copy and paste. It's simple, so don't make it difficult. It's just like saying New York. It's the same as Apple City. So if somebody asks what is the Apple City, you say it's New York. Or Boston. Do you have another name for Boston?
Baytown.
Yeah, Baytown. So what is the Baytown in America? Boston, same thing. What is class less than? It's the same as the upper boundaries. That's why I copy them. Now the last thing we want to compute for this table will be called the cumulative frequency. Cumulative frequency. Frequency is kind of related to that frequency. It's just that this part is accumulated. Accumulation. You're going to be adding and adding and adding. How do we find the cumulative frequency? Simple. Pay attention, ask questions when the need arises. To find the cumulative frequency, you will need to depend on class less than. Class less than. Class less than. On this table, where can you find the class? First column. You want the classes that are less than these numbers. Can you connect the two? Class less than. Everything is in there. So these are the classes. You want the classes that are less than these numbers. So look at this. This is 22.5, right? Yeah. Let's go to the classes. Which of the classes is less than 22.5? 17 to 22, right? What is the frequency of that class? I put it down.
So is it just going to be the same as the frequency? Yeah. Can we just say that now?
Not yet. I think wait till we are done with the third one, then you can define that. Let's go to the second one. What number is this?
28.5.
Now we want the classes that are less than 28.5. How many classes here are less than 28.5? So we will need the sum of these two.
I remember this in homework.
So what is that? I think it's beginning to make sense now. Gradually it will make sense. Don't worry. Don't push it. 34.5. Class less than 34.5. So we go back to the classes again. How many classes here are less than this? This class, that class, and that class. So you add them.
That's why it's called cumulative.
Awesome. Awesome.
Somebody's listening, huh?
All right. 40.5. So 40.5. How many classes are less than 40.5? We go back here. 1, 2, 3. Oh, 4, 21. So now that you know the parting, do we really have to go back and forth? No, really. All you have to do is just add the next frequency to this, to that, until you get to the end. But hey, if it doesn't make sense, move back and forth. 21. We go to 46. So it's going to be 22. 50. Still 22. 58. 23. Is that okay? Good. I'll quickly draw another table on the other side. This time I'm going to give you my own classes. since you already do know how to create these, because even in your homework, nobody tells you how these things are created. And then we'll go through the same process. Afterwards, I'll draw the graphs, and then we will continue from there. So assuming that I give you this, class, together with their frequencies. Let's say this is 10, 13, 6, 4, 8, and 10. So this time we have another class together with the frequencies. If we are asked to find the class midpoint, how will we go about that? Add the two numbers and divide by 2. That gives you the class midpoint, right? It's as simple as that. We're going through this example to reinforce everything we've said so far. So it's going to be 0 plus 9.9 divided by 2. What is that equal to? $4.95. Then we go to the next one. 10 plus 19.9 divided by 2. 14.95. 20 plus 29. So who can guess the next one? Why do we have to add 10? How do you determine the class? That's the class with you, right? How do we determine the class width from here? The vertical column. So 10 minus 0 is 10. If that gives you the class width as we learned last time, then all you have to do is to just keep on adding the 10. It will take you to your final destination. You don't have to move back and forth. But hey, if it doesn't click, just do it the manual way. Add the 2 divided by 2. Add the two numbers divided by 2. So this is 34.95. Add 10. 44.95. Add another 10. 54.95. Do I have to add another 10? Okay, because that's all. There's no 60. Great. But sometimes you can have fun, keep on adding the 10 and realize you are out of range. 1, 2, 3, 4, 5, 6 of them. So class midpoint, I don't think I have to talk about that again. We're done. The next thing that came up was the class boundaries, right? So let's do the class boundaries again. How do we find the class boundaries? You have to find the continuity factor or the correction factor. Why the correction factor? Is simply because there are gaps between these intervals, and it's our duty as a CJ to close that gap. To close that gap, that is when the continuity factor comes up. So to find the continuity factor, as we said, you will find the difference between a lower limit and then the preceding upper limit and divide by 2. I chose this example so that you will not generalize and say that, oh, it's always 0.5. It is not always 0.5. But at some point in time, we will establish that it's always 0.5. But for now, since it is the introductory phase, it is not. We find it, we compute it, and whatever we get, we work with it. Make sense? Great. So in finding the continuity correction factor, it could be 10 minus 9.9, right? Over 2, which is 0.05, which is different from the 0.5. Any questions, any concerns? Beautiful. So what are we going to do with that? We're going to add it to the upper limit and subtract from the lower limit. Does that make sense? And when you do so, you get the class boundaries. So it's going to be 0 minus 0.05, which is negative 0.05. 2. Add that, 9.95. add this number, the correction factor, to 10, 10.05, or, no, we subtract. So I was wondering why they are not the same. 9.95, add it to this. 19.95, subtract 19.95, add 29.95. And also, if you look at this carefully, the class width is also playing a good role here. Add 10 to this, you get that. Add 10, you get that. So you can keep on adding 10, 10, 10 without having to go back and forth. Add 10, add 10. Class width is an important tool. And of course, if you know how to find it, it will make your work a little bit easier if you are working manually. So this is 29.95. Add another one, 39.95. And then 49.95. 39.95, 49.95, 59.95. So far, so good? How do we find a class less than from here? The upper boundaries. So help me list them. What are the upper boundaries here? 9.95. 1995, 29.95, 39.95, 49.95. Boom. These are the class less than. And with the class less than, I believe you and I can find the cumulative frequency. And once again, we have to move in between the class less than and the classes. But with time, you get to know, oh, it's just the addition of these frequencies to what the preceding frequency in that column. So we have 9.95. How many classes are less than 9.95? Just the first one. So 10. 19.5, two classes here are less than the 19.5. Therefore, we combine these two, which is, the next one will be by adding this 6 to the sum. 29, add the 4 to that, 33, add the 8, 51. Which is that. And we find all these simply because we want to draw these graphs. In order to draw the histogram, you will need a vertical axis and then the horizontal axis. If you look at your slide, it tells you that to draw a histogram, you need the frequency and the class boundaries, right? Now, the vertical will be the frequency. This will represent the frequencies. And then in the bottom here, we have the class boundaries. We're trying to draw the histogram. So to draw the histogram, first of all, you need to calibrate this axis. How do we do that? You first have to go to the frequency. Once you know of the highest frequency and then the lowest frequency, you can decide to move either in 1s, in 2s, in 3s, or in 5s. It's all up to you. So since I have, what is the maximum? 9. 1, 2, 3, 4, 5, 6, 7, 8. I think I can go up to 9. 9. So we can move in 1s. That. We have 17. Now, class boundary is 16.5 to 22.5. So we are going to illustrate that on this curve using a rectangular box. So what is the height? 9. So I will start from there. My graph is going to be a little bit crooked because I'm drawing with free hands. So it starts from 16.5 to 22.5. Remember, I'm using the class boundary, so 16.5 to 22.5. When you get to the next point, you realize that, oh, the end point is the starting point. So there is no gap between the bars, and I think I talked about that last time. So 22.5 to 28.5 is 8. So I'll just extend this line down to 28.5. Maybe I should use a different color. Next, 28.5 to 34.5. That is the class boundary. That corresponds to this 3. So this is going to be 3 down here, which is 34.5. From 34.5 to 40.5, the height is 1. So it's supposed to be somewhere there, which is 40.5. The next is also 1, 40.5 to 46.5.
So when you're doing these graphs, you don't want to use the regular class boundary, the first one.
No, you can. If you use this, you have gaps in between, and that becomes a bar chart.
Would it tell you if it's a histogram or bar chart?
You can tell.
Histogram is close together.
Histogram, yeah. Over here, 46 to 52 is 0, so it's a gap. 52, and then the last one, 52 to 58. So that is a histogram. Rectangular blocks, no spaces in between. Now this guy here is speaking volumes. But the first thing we want to do is just learn how to graph it, and then we will talk about the interpretation, because it means a lot. It's telling us so many things about our data over there. Is it a good data? Is it a bad data? Everything can be deduced out of this graph. So that before you even use it to make any analysis, you can tell yourself that, I think the data is no good. Let's start again. Maybe you need to get more information. Maybe you have to avoid a little bit of variation in there, whichever way it is, or probably introduce more randomness into your selection of the sample. Is that okay? With this, I think we can also graph the histogram from here. Does that make sense? It's the same thing. Now, let's look at some of these things, because I wanted to talk about this negative number here. Statisticians like doing that, and I believe since you are taking statistics class, you can also adapt. Now, look at this. You notice that the numbering here is uniform, right? It starts from 1, 0, 1, 2, 3. Difference is always 1, 1, 1, right? But then look at the bottom here. We start from 0, and all of a sudden we jump to 16.5. And then to 22.5. So here the gap between this part and that is 16.5, and it changes to 6, 6, 6, 6, 6. It's not uniform. So what statisticians usually use is this guy. Sometimes we break off. Oh, I'm still holding that. We break the graph, the axis a little bit, and then put that zigzag thing in there. Now, you've been seeing this over and over again. You have cell phones, right? Anytime you connect to the power outlet, you see this little thing next to your battery. Statistics is everywhere. It means it has contact and you have continuous flow. It's on your computer. It's everywhere. So this guy here, don't joke with it. So anytime you see this, what? I call it zigzag. You know zigzag, right? Zigzag, Z-I-G-Z-A-G. Great. It's just telling you that the graph here, the numbering here, the scale is not uniform. Can I do that? Yes. I'm going to use this part to illustrate that, but I'm not going to draw the entire graph. So, assuming we want to draw the second histogram using this information, is the class boundary together with the frequency. I have this axis and that axis. This is 0, right? Now the frequency, what is the maximum? Yeah, 13. Highest is 13. So you can choose moving 2, 4, 6, 8. It goes on and on and on and on. The first class boundary, where does it start from? Negative. This is a number line, right? On a number line, the negative must always be to the left of the 0. But a statistician, you don't have to do that. You can put it on the positive side. And how can I do? Put that little zigzag. So I'm just going to take some part of it off and put in that little thing. That allows me to do anything. So the first height is 10. I go up to 10. And I can put the negative 0.05 here up to 9.95 there. Nobody can punish you for that. Why? Because you gave us notice that you're about to do that. Yeah. So it's very important. When you read through a lot of these statistical literature, you may see some of these and probably want to know, why do they have it there? That's what it means. Yes?
Can you specify like how big the negative goes? Like that one only goes to negative 0.5. Can you go like to, I don't know, like negative?
Anything you want to do. This part is not supposed to be uniform. As long as you put this here, you can put anything there.
But do you have to specify the value, like what is it covering? Or
Oh yeah, I think I've been writing that. Is that what you mean by that? Or you mean you can skip?
I meant the first part. Do you have to specify what it amounts to?
This?
Yeah.
No, you don't. As soon as you put it there, it takes care of everything. Nobody cares about the magnitude. If it's 1,000, if it's 1 million, if it's negative, nobody cares. But at least you have warned us that, hey, it's not uniform down here, so be careful what you do with that. Is that okay? Good. So we know a frequency table. Out of the frequency table, one can find a class midpoint, class boundaries, class less than, cumulative frequency, and the rest. Now, there are a lot of graphs that can be constructed out of these, but I'm just concentrating on the histogram because that's the most important thing. If you want to do the rest, pretty simple. You have the information in the PowerPoint note. So you have to do is put the frequency on the vertical axis and the rest on the horizontal and then plot. And I choose to concentrate on this because of what we can get out of this. So now we want to concentrate on the histogram. Histogram can be interpreted. Yep.
So what if you have a couple that are negative? Is it still okay just to have one squiggle?
It doesn't even matter. You can have everything negative with this little thing. Put all, yeah. It doesn't change anything. If you want to put it on the left, nobody stops you from doing that. But we want to stay over there. Great. I'll quickly draw this, right? Without the number. This is 13, so the 13 will be up there a little bit higher than this. Down, followed by 6, which is down here, and then 4, which is over here, and then we have 8, somewhere there, and then 10. You notice that there are no gaps in between them. That's what makes it a histogram. Why do we need a histogram? It's simply because we learned earlier on that we have a big population, and your goal is to select a small, a subset of the population. But you want to make sure that the little you select is a true representative of that big set, right? So now that we have selected just a little part of the bigger set, what does this graph tell us about that little information? That's what we want to do. So I will give you the general definition, and then with that, we will come back to these graphs you and I have drawn together and then interpret it. And that will be question number. I mentioned that earlier on, right? Oh, question. That is question number 4 on the test. Number 4, the graphs. The interpretation of, or probably I can ask you to graph it. I know.
Well, when is our test actually? I'm better writing saying that.
Test is after the 3rd chapter,
What chapter are we on now? Like
chapter
first?
2.
Oh, okay, good. So next class we're doing chapter 3.
Hopefully.
Okay, good.
And then we'll be heading towards there, and I'll let you know when.
What if it's snow again?
We pray we don't have this severe weather again. But if we do,
I thought you liked the snow.
I do.
Yeah.
But I hate shoveling. So funny, yesterday around probably 2 o'clock, I'm like, oh, let's go out and shovel a little bit. I came back in the night. I hate Boston. All right, so back to the histogram. Under normal circumstances, whenever one draws a histogram, this is what you want. It's just like buying a new car. When you buy a new car from a dealer and it says the car is new, at least there shouldn't be any mileage on, on the odometer. Otherwise, it's not a new car. That's why when you have an old car and you're selling, I mean, a prospective buyer will ask you, how many mileage do you have on it? I have 100,000. Like, oh, you can keep it. Or probably 20,000. Yeah, that's manageable. So if it's a new car, mileage must be 0, right?
Yeah.
So that's what you have in mind. Or you buy a new shirt, a new dress, whatever you want from a shop. You want it in the rubber. You want it intact. You want like a textbook from the bookstore. Oh yeah, I like the packaging. Nice. When it comes to histogram, when you're drawing it, this is what you must expect. You kind of have the tallest bar in the middle, surrounded by equal, not necessarily equal, but probably the same equal number of bars around it. Yes. Kind of the tallest to the least and the tallest to the least. So the tallest bar, it could be a bar or bars or whatever, must be in the middle.
What if the data at hand doesn't allow you to get a graph like that?
It will never allow you to get that. That's why we're going to learn how to interpret that.
Oh,
Because if you look at our examples, the ones we did, none of them look like that. That's right. But under normal circumstances, this is what we're supposed to get. Now, if you happen to get this type of graph, it means your data is good.
Yeah, it's on the homework too.
Oh, you say, okay. It means you have a good data. Now, a name for this one is called symmetric. This is symmetric. Another name for symmetric is normal. Now, normality comes in. And I believe, even if you haven't heard of symmetric before, you know normal. Oh, don't mind him, he's not normal. Oh, don't mind her, she's not normal. Now, when people are not normal, you don't go to them for suggestions and ideas, do you? So if the graph, the data is not normal, why do you want to use that? It doesn't make sense. Can you make it normal? Yes. Do we do that in this class? No. It's a different class altogether. So our goal in this class is just to learn which of them is normal, and then the ones which are not normal. Now, it's also possible to get this type of graph when you draw your histogram. So we have the symmetric graph, and then we have the asymmetric. Asymmetric means it is not symmetric. So here you notice that the tallest bar is not at the center of all the bars. If it happens this way, we call this asymmetric. Now you notice that we have a lot of these bars to the right, right? Do you see that? We have a lot of bars to the right. So you will say that this is skewed to the right. Some books will refer to this as right skewed. Skewed to the right skewed, same thing. So can you also have?
Skewed to the left.
Excellent. A lot of bars to the left of the tallest bar. Skew to the left. This is also asymmetric. Left skew. So anytime you're working with any sample, your hope or your goal is you don't get any of these. If you get that, then you know that my data is not going to give me, any good results for you to make inferences or probably some generalization about the data. So we can go back to this guy. What type of graph is that? Asymmetric, right skewed. It means it is not normal. If it's not normal, it means you will not go to this guy and then ask him to give you information about the population because it's biased. Good, biased is a good word. It's biased. So what do you do if you have this? It means start the whole thing again. This time, you would have learned how to eliminate error. As we move along, we will learn a little bit about error. So you can then factor that into some of these things. So that is why the histogram is very, very important. Because before you even start doing the analysis, you know that this data is not good. So you can even give a caution. I know my data is not really good, but I still want to go ahead with the interpretation. Do that. So on the test, yes.
I mean, how do you know that that means the data isn't good? What if that just is the result? Why is that not true?
Excellent. So you buy a car, and then they tell you this is a fresh car, but you see 1,000 miles on that. Is that a new car? No. No. So as soon as you see this, yes. No. I understand you. Her point, if I understood her, is this is my data. This is going to work. But all of a sudden I get this. How do I know it's not? The graph. So the graph speaks volumes. It doesn't mean you cannot continue with the analysis. What it means is there's something wrong somewhere.
But doesn't that indicate like an equal distribution? Like say these numbers at the bottom represented age.
H.
And you have that many people in that age range.
Use the same word, equal distribution. You remember when we were talking about random sampling, giving everybody equal chance of being selected.
So if you use that and that's the case, then there should be an equal distribution in your graphing of the data?
No, in that case, you are saying that we should reach perfection. Nobody is perfect under the sun. It's only God.
Okay.
So even when you use the best of materials, the best of resources, truth is, you will never get this. You can get something very close to this, but you will never get this. And throughout the semester, you realize that we either get this or those things or something very similar to that. With that, I want us to turn to our textbooks and then look at some of these graphs so you get to know how they look like. And then, of course, we do the interpretation, and then I'll be certain. See this one?
Yeah, that's asymmetric.
Which one is that?
Oh, it's green. No, it's
Looks symmetric. Green. But look at this one. They say the one in red. It's not even asymmetric. All the bars are almost the same, right? It's called uniform distribution. It's uniform. We've got to do something about it. Or you can keep it as it is and work with it. And I think our graph was, the second one was almost, guess that we missed some bars. if these guys had come up a little bit, we would have had a uniform distribution where the heights are almost the same. What do you think about this one? Because we kind of have a lot of bars to the right. And this one to the left. All right, so any concerns? We okay with the graphings? So to summarize this, we said that you have qualitative, quantitative. The graphs for qualitative will be pie chart and bar chart. When it comes to the quantitative, histogram, ogive, Pareto, time series. We talked about the time series last time and all of these. Great, and it's very important for you to be able to interpret interpret a histogram, which is an integral part of the course. So I'll take this out. Do you want? No. And we go back to frequency table, done, bam. Chapter 3.